Good evening, everyone. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet every second Wednesday. The meetings are free of charge and open to the public. We cover a variety of topics related to Azure, infrastructure as a service, platform as a service, or software as a service. You can find meeting information posted on meetup.com at the link at the bottom of the slide, and that covers past meetings and as well as future meetings. Some general information, please keep in mind participation is always encouraged. And like we always like to say, the only stupid question is the one not being asked. So feel free to jump in with any questions or comments. However, when not speaking, I ask you to mute your microphones to prevent any background noise. And we like to keep it casual but organized in the sense that jump in with questions and comments when needed. But at the same time, we want to give our speaker enough time to go through the demos and the slides. And lastly, the presentation is being recorded and will be posted on YouTube with the link provided in the chat a little bit later. And so with that, brings us to our feature presentation for tonight, which is Christos Matskas. Am I pronouncing that correctly? Excellent. So Christos works for Microsoft, and he'll be presenting on service principals and managed identities. Christos is a developer advocate for Microsoft Identity, has over 16 years of experience, and he is helping developers leverage power of identity in the cloud. He's also very passionate about open source, and he's contributed regularly to numerous OSS projects. And so with that, I will turn it over to Christos.
Cool. Well, thank you everyone for your time today. I appreciate you taking time from your busy lives to listen to me. With this exciting topic about service principals and mass identities. Now, I don't know how many of you have to deal with them on a regular basis, but this is definitely a topic that everybody struggles with. Our team struggles, everyone at Microsoft struggles, and since we struggle, I assume that everyone else out there struggles. I was in a meeting yesterday, and one of the PMs for the storage team said, well, what is really the difference between a service principal and a mass identity? But before I get started, if we were in the same room together, I would ask you to raise your hand and let me know whether you know what either of these are before I go into explaining each one of them. In fact, I will cover that anyway. But how many of you have worked with service principals and mass identities? Put in the chat, and as we go through, I'll see the numbers. Also, feel free to interact and ask me questions as we go through. Don't wait until the end. I would rather answer something that's pertinent to the things that we're seeing. And there will be quite a few demos to explain what they are. But security has definitely changed. And for us, it's an opportunity to also present and speak to people about things. So if you do think like this, if you want to learn more about identity, if you want to learn more about end-to-end scenarios, then we do have a weekly stream on Tuesdays and Thursdays. We go online for about an hour and we chat to our favorite people and build things live on the stream. End-to-end scenarios, Azure Functions, .NET 7, .NET 6, making them work, Node, Python, no matter what you do, we'll show you. We also do IT things that sometimes developers don't get a chance to work with, but they help you understand how to set things up and increase security. Make sure to follow us on Twitch. And we do have a fantastic Discord community that really helps with asking questions and getting people from the community or the engineering team answering them, almost like an informal forum that you can find things. And if we can help you there is a fantastic forum that we have officially allocated PMs and devs to help with answering questions. Now, I've been working with Azure for many years, almost 12 years now. And I've always been a developer. So for me, it was important to use technologies and run them on Azure and making them work and making them secure. Obviously, I work in security, and security is important to me. But security is very, very hard as well. Now, at Microsoft, this slide is very weird because, as you can see, the only Microsoft thing that we have here is actually identity. But we don't really care where you run things, especially when it comes to identity. It might sound counterintuitive. Obviously, I would love for you to use Azure. I would love for you to use all our products. But we know companies out there are multi-cloud these days. We know that companies will use different tools and languages that are not always aligned to Microsoft. We want to make sure that everyone is secure and everyone is doing things in the right way. So we don't care whether you're using Bitbucket, IntelliJ, or PyCharm. In fact, IntelliJ now has an Azure Active Directory plugin. So some of the things that you see today, like creating app registrations, can be done through the ID. We work with our team to make it happen. We don't care whether you're running on AWS or Google Cloud, because you still need to authenticate users and you still need to secure your resources, especially if they're cross cloud. And then languages. We have libraries in most of these languages. And the Azure SDK team has done a fantastic job in creating idiosyncratic or idiomatic languages and SDKs for you. But if you are using any of them, you'll find good support. And in the end, we don't really mind if you want to use serverless or Kubernetes or bare metal. We want to make sure that you're successful when it comes to identity. That's why identity cross-cuts all responsibilities. Identity cross-cuts everything, from signing into your computer in the morning to opening Visual Studio to do some development, to deploying things securely through CI/CD, to actually running things securely on Azure, and then interacting with external or internal users, however your application is being set up. Now, if you are on the Microsoft ecosystem, then there are some added benefits. I mentioned Visual Studio. Now in Visual Studio, you have to sign in to get your license, and now we know who you are, and we can also allocate certain things to your account, like the ability to deploy stuff from directly inside Visual Studio. You might say, well, why would you want to do that? Obviously, right-click publish is not something that we encourage, but in some scenarios, you might want to test something. You might want to create a quick proof of concept to deploy to Azure, or to call an Azure service and see how it runs. Like, I love running Azure functions locally. It's amazing. Great tooling. And I can authenticate against Azure, and I can call other services or get triggered by events that are happening all local on my machine. So it's not just right-click publish. And then you have all this rich ecosystem. The Azure SDKs work great out of the box with Visual Studio and Visual Studio tooling and the CLI. Then we have the Azure services that do support identity. You have to know who you are, or we have to know who you are, so we can let you through the door and let you do things with your data, or lock down things if we need to. And then you have Teams and SharePoint and Exchange, and then the Power Platform, all working together with the one identity service provider, Azure Active Directory. When it comes to service principals, the explanation is simple, right? We use them everywhere. Anywhere that we cannot use or we don't want to use a user account. For example, I have an API that needs to call another API and doesn't need to know who the user is. I need to authenticate somehow. In fact, we need to make sure that we're authenticated over HTTPS, passing tokens back and forth. For that, we need to use a service principal, because the API authenticates as a service. Therefore, in the cloud era, a service principal is a service account. If you have ever worked with intranets and you have system accounts, all managed by your Active Directory, let's say your SQL server needs to run under a specific context, that service account would exist on your local intranet. But in the cloud, we don't really have intranets. We need to give services identities, so we know how they can run and how they can access other services. So service principals are used anywhere that we cannot have an interactive user sign-in. Service to service, service to data, whatever you want to call it. But service principals are plagued by a lot of problems. And the biggest one is that they're glorified username and passwords that we pass around. If you are creating a console app and you need to authenticate to call a service, then you need to store that secret somewhere. And that secret is usually something that ends up in config files. And this is what hackers love to do. And that config file might end up on GitHub or some other public repo. And then the hackers don't really have to break in, they have to sign in. It's weird, but hackers these days are extremely clever and lazy. They will look for credentials rather than trying to have to break into your operating system. They won't do that. They will scan around your local files. They will look into the secrets files that your Visual Studio.NET generates. So they know where to look. And service principals are one place that they look, especially over privileged service principals, because we'll just go, well, just give it access. It will do whatever it needs to do. And then we forget about locking them down. We forget to delete them. and they live there. So that's the biggest problem with service principals. Another problem is that they have credentials that they expire. Whether you're using a certificate or a secret, those credentials expire. And that becomes another problem because suddenly you have services that stop working in production and nobody knows why until they figure out that the account that it was running under has expired credentials, which is always a problem. And we tried to solve that. We said, hey, what if we were going to create a separate style of an account that still looks and behaves like a service principal, but users don't have to worry about credentials? That's the man's identity. So if you are on Azure, every service can have an identity, and that identity is in effect the service principal behind the scenes, but we don't call it service principal, we call it the managed identity, because we manage that identity for you. We give you an ID that can be used to identify your service, or you have a name. That ID can be a name as well. And what happens is you assign that identity to a service, and then that service can communicate with other services without having to pass credentials. I mean, they do pass credentials around, but you don't see them. It's all happening behind the scenes. And that's amazing because now you don't have to have secrets in your files. I love it. It's amazing. There's another problem there. Can anybody guess what the problem is? It is Azure only. So it only runs on Azure. And that sucks because managed identities are fantastic, but not everyone runs on Azure. There's a way to extend those capabilities. Has anyone here heard of Azure Arc? It's a fairly new service, newest. It's been around for a year and a half now. And the idea is that you can deploy Arc agents onto other devices anywhere. It can be on AWS, it can be on your on-prem environment. And suddenly those boxes, those VMs, start behaving like actual Azure VMs. So they get the nice thing, or that your network now is extended beyond just the physical presence of Azure, but you also get other things like a managed identity. So an Azure Arc device now has a managed identity. And for fun, I can also join my computer that sits under my desk with Azure Arc. And now my local machine as a developer has a managed identity that I can use to authenticate to Azure, which is awesome. There are services that are earmarked to be deployed to Azure Arc, like PaaS services, Azure Web Apps, Azure Functions, I think Azure Container Apps as well. And I was so excited about that because, like, you know what? Imagine if I can run web apps on my desk under here with Azure Arc, and I get a managed identity. I was so excited. I reached out to the PM and said, "Is that thing happening?" And he said, "Oh, no, not yet. I know that you're extremely excited about this because you're passionate about managed identities, but we are working on making it happen. So expect over the next few months to see an announcement that says Azure Arc services now support managed identities, which is, again, something that we want to see more people adopting. And then there's a third thing that we announced very recently, which is the Workload Identity Federation. And Workload Identity Federation is a service principal that uses OAuth 2 to authenticate. Protocols. I hate protocols, right? I mean, who wants to know about OAuth 2? I don't. Nobody wants to know about them, unless, of course, you want to get deep into them. But as a developer, I just want to make things happen. So what happens in effect is we say, hey, we have, let's take GitHub Actions, for example. We'll say Azure Active Directory knows GitHub, or Azure knows GitHub. So we can establish a relationship and can say, when a GitHub workload needs to call or speak to Azure to deploy services, let's say through a GitHub action, instead of passing credentials around, how about if we have GitHub communicate to Azure with Azure behind the scenes, they exchange tokens. So GitHub says, hey, I have an authenticated action here that needs to speak to you. How about if I give you this token, you validate it, and then you give me back an Azure token? Would that work? So we establish a trusted relationship between these two tools or components, and it just works. So when we go and do the demo with the GitHub action, you'll see that we don't really have any secrets. It's just the tenant ID, which tells the GitHub action where to go and look for the trusted relationship. And then we have an app ID that identifies the app that has been configured with the right permissions. And we're extending that to other services as well. So Google now, if you're running workloads on Google, we can say, how about if this function that is running on Google can go and grab a token from Azure to call my SQL database? without passing credentials. That's the important thing. And Kubernetes, not Azure Kubernetes. Obviously, Azure Kubernetes already has a master identity, so it makes no sense. But what about Kubernetes running on your local on-prem or somewhere else again? You see the idea? We are allowing you now to extend your authentication context and allow you to be secretless without having to configure or have a very elaborate configuration. There's a little bit of configuration, but trust me, it's amazing. And finally, yeah, we're trying to extend it. The one thing I saw and really blew my mind was having Azure Active Directory using Workload Identification with another Azure Active Directory. So imagine two different tenants. You have Contoso here, and then you have Microsoft here. And then the Contoso guys say, hey, we need to access things. Can we exchange tokens? So there's no relationship between, like, the users here are not part of the users here. They're not external identities. I don't know how many of you have done external identities. They're not federated. They haven't been added. We just say, hey, this user, I know it's trusted, and this Azure Active Directory knows this Azure Active Directory, so let them exchange tokens. And that's amazing. It's like, that's a perfect example. In effect, any service that has an OAuth endpoint that Azure Active Directory can use can now almost adopt Workload Identity Federation. There are some limitations. So we go from the least secure service principals to the most secure, which is Workload Identity Federation. And the order goes, service principal runs everywhere, but it's super insecure. Mass identity runs on Azure, and then with a few small exceptions, we can extend mass identities to run outside of Azure. And then we went, forget about Azure. How about every other service that is not Azure and needs to speak to Azure? It's perfect. So let's go and do some demos. I don't think I have any more slides. Yeah, demo time. So we'll start with, well, my battery on my mouse is running low. That's a weird thing to see. We'll start with this. Let me make it bigger so everybody can see. Usually when we use the CLI, I like to use the CLI for most of the things. We do an AZ login, and then when you do AZ account show, when you issue this command, you can see who signed in. The big problem with signing in as yourself is that usually you're overprivileged. Like, I'm an owner of my Azure subscription. I can do some serious damage. What would happen if somebody was able to get hold of my machine through phishing or through some stupid thing that I did on my machine, and they could come here and get access to that account? That account can go and delete things in production, for example. Lots of developers do have access to production systems, even though they shouldn't have, because it's a small company and somebody has to fix the issues in production. So what we want to do is we want to create a service principal that has less privileges. So you'll see here, this is a service principal signed in. And if you want to create a service principal, all you have to do is AZ AD SP create or RBAC. I don't want to use SDK auth. You need to give it a subscription, obviously, so it needs to know where it needs to be created. Look at that, I gave it a name, CM to delete, but I don't know if that exists already. So let's do that. And sometimes, in fact, most of the examples will have contributor there, which is super dodgy because you can do lots of things again. So I want to make read there. And the scope right now is my whole subscription. And this will go ahead and create the underlying, oh yeah. Obviously, I cannot create a new service principal because I'm signed in as a service principal, but this is the command that would come out of that. And that would dump a JSON object that will have the app ID, the secret as well, which also stays in your history, etc., etc. So what I did is I said, hey, you know what? I have a .NET app, and it needs to sign into Azure to call some services. How about if I use a service principal? I don't want to use my account to temporarily test that. And then I'm going to delete that service principal because it shouldn't have access to production systems. And remember, it's a username and password that sits somewhere. In fact, if I do login, check this out. It was in my history. So you can see here my password. Don't dox me. Anyone that has access now to this can go and sign in with that account. They don't need to be part of the tenant. Just sign in. Dangerous. History can be dangerous, as you can see. Right, and I have an application. Now, it makes sense to see it in action. what does this application do? It's an ASP.NET application. If I remember, it's an ASP.NET 7 application. It is a 7. Let me make this big so everybody can see. I like to play with the latest and greatest and break stuff because that's what they pay me for, to break things and then make them work. The whole point here is that we have a web app, and something very common, right? We put secrets here, or we put sensitive information. It can be blah blah blah, but I don't want it to be in a config file because I check this in. This is checked into GitHub. If you go to my GitHub repo right now, you'll see there. I want to eliminate the need of storing any secrets. ASP.NET does a fantastic job in bootstrapping the config with Azure Key Vault. Azure Key Vault is where all my secrets go. They go there. There's fantastic auditing. There's versioning. I don't have to worry about, falling in their own hands. In fact, I don't even know what the secrets are. Now imagine this. Your IT team says, this is the connection string to your database. It's in Key Vault. All you have to know is reference that value. Perfect. I don't need to know it. And then what I'm doing here is I'm saying create a configuration, line 2, right? Bootstrap the config. I do not want to do that. I want to do this. And I'm also adding a Key Vault configuration. There's an extension for Key Vault. Now, obviously, I need to authenticate to Key Vault. In the past, we would use a key. The problem with the keys in Key Vault and storage is that they're the keys to the kingdom. You can do anything you want with that key. You can delete, create, block, anything you want. So they're overprivileged. What we want to do is have a service principal that has very limited permissions. So this is the configuration, and then we say I want to sign into this Key Vault with this URI, and then I want to use the Azure CLI credential. The Azure Identity have done a fantastic job. The Azure SDKs team have done a fantastic job in providing a consistent experience in signing in to all the services. Usually, most of the examples will have the new default Azure credential, which is great for getting started. The problem with the default Azure credential is that most likely you won't know where the token came from. So I have Visual Studio authenticated to Azure right now. I have my Visual Studio code down here. I have my account signed in down here, sorry. And then I might have something in PowerShell. I might have something in my environment variables. And what the default Azure credential object will do is we'll go iteratively and try every single one of them until it finds an authenticated token. Now, my authenticated token may come from Visual Studio Code before it even goes to the CLI, and therefore I will be acting, or the code will be acting as Christos, not as the service principal, which is, again, overprivileged. We want to use the least privileged approach. And the chain token credential is awesome because I can explicitly say, I want you to try these credentials in the right order. And if this fails, then go to the next one. And I only want to try 2. On my local machine, I'm using the Azure CLI. On a production system, I'm using Master Identity. And it does it in a graceful way so it doesn't crash when it says, oh, I can't find the credential here. So it will iteratively try until it can't find anything, and then it will crash saying, I can't find a credential. And with that, we have an authenticated session, and it will go to Azure Key Vault. It will try to find any variables. It will just iterate through them. And if it finds something that matches this value, it will populate it. So that happens at the startup. But there might be a case where I don't want to do it at startup. At startup, you might be doing it because you need to access the database to load some data, and you need to know early on how to do that. But you might have a piece of code somewhere, like here in my pages, where I want to access secrets at runtime. Again, I would use the exact same approach. I would instantiate a secret client. Not the best approach here, obviously. People that have been doing .NET for a while, like, why is he not injecting the service in there? Yeah, inject it. This is a demo example, right? So we're not injecting it. We're just instantiating here on this page. And then I'm not even checking if it's been instantiated before. And then we're just pulling the secret. Now I do have a separate secret or a different secret called KV secret. And I'm using the exact same credential approach to pull it out and display it on the page. Let's see this running. .NET Run. Any questions so far? Some people have used service principals. Mark says both, and Dane says mostly service principals currently. It's absolutely fine. Okay, we're up and running. Let me take this here so you can see. The fact that it started out of the box and we didn't crash means that that's a good sign, because otherwise here we would see a fat exception saying either this service principal doesn't have permissions to your Azure Key Vault, or it can't be found, right? It could be one way or another. So with that, we know that things are working. And this is coming from my Key Vault. And once we switch to this page over here, it will go to Key Vault and pull that out. Just to prove the point, we're going to go back to our Azure subscription. I do have a Key Vault. That's the Key Vault that we're referencing. And I'll make this big, obviously, so you can see. So secrets. And we have a KV secret. Can you tell how many demos I've done with this? Quite a few. I change it every time. And I'll keep it a surprise. I didn't mistype. Fat fingers. There you go. Let's create that. You can also set expiration dates. And if we come back here and refresh the page, yeah, hey, it works. My IT team or whoever is dealing with my Key Vault can change things on the fly. I don't have to know. Maybe somebody rolls a third-party API or somebody rolls the keys, and you want to continue working as you do. You don't need to know what the secret is. Somebody will pass it on to Key Vault, and then Key Vault will pass it back to your application, which is fantastic. And then we have, obviously, as I said, a full audit here to know exactly when things change and why and by whom. Another problem with service principals is that now everyone using this same service principal will sign in as the service principals. Nobody knows that Christos is accessing data, right? It's the service principal accessing data, which can cause headaches when it comes to auditing for certain systems. So service principals do solve certain problems, but they also create other problems. But anyway, there you go. We have things working. Now I'm a config secret. If I go here into my secrets and change that, it will not be reflected to my code until I restart my application. And this is how things work locally now. I could do the same with Sql. I could have a service principal that accesses Sql, and I can have another service principal that accesses storage, or I can give the same service principal the same permissions. How did this work? How did we make things happen? Right now, or when it comes to Azure Key Vault, there are two ways to configure access. One is with Vault Access Policy, which is the old way of doing things. And then there is the Azure role-based access control, so Azure Arc. Yeah, Azure Arc. The first one, the access policy, you find the account, you add a new access policy. Check this out. I've got CM to delete. You see this? And then that's the old account I was using. And then here we gave permissions. We gave get and list permissions to our secrets. This is great, but also not great. My application is only accessing 2 secrets, but this service principal has access to all the secrets across everything in my Key Vault. And that's a big problem. You cannot really segregate and secure. In the past, people would create separate Key Vaults if they wanted to have clear-cut segregation. Now, with RBAC, you can do secret level or key level permission access. So you can say, I want the CM delete account, that service principal or master identity, to only have access to read this secret. So you can do it at almost at the row level, right? Which is awesome. Right now, as you can see, I cannot define anything here. But if I were to switch my access policies to RBAC, that capability is there. And that is amazing because now you can have per service principal or per account permissions per key and per secret. Amazing. That was in high demand by a lot of customers in the past. There was a workaround with the separate key vaults, but not nice and easy to maintain. So what happens when we deploy this application, right? Let's see it in action on Azure. So I'll go back into my resources, and obviously I deployed that a long time ago, and I'm keeping deploying it. And the demo is called cm.NET Conf demo. So it's been there for 2 years, but the principles remain the same. Nothing should change in terms of security. So what do we have here? We have the exact same application. Let's browse to it. See? And in fact, if we jump to the Key Vault Secrets, you'll see that it says, hey, Cleveland rocks. Because we all know that Cleveland rocks. Even though I only spend one day, I need to spend more time there. Maybe next time you invite me in person. How about that? I'll fly gladly and see you all in person when we get back into in-person stuff. Okay. So how does this work? Obviously, we don't have a CLI here, which is weird, right? It would be weird to have an underlying CLI just to allow us to authenticate. But we do have an identity. I would say 90% of the services right now support a managed identity. And here is where we talk about the differences. But for now, you'll see object principal ID is that. If we go back to our Key Vault, let's do that quickly just to see how does this work. Under access policies, I do have my cm.neconf demo. That's the managed identity name. And I'll explain how that happened. Again, the exact same permissions, so you can get at least the secrets. Let's go back to the web app. Hope everyone is with me so far. I see that Sam is saying deal. Be careful what you wish for. Okay, identity. When you create an Azure service, like a web app or a function or an ACA or whatever, you can assign it an identity, a service principal called managed identity. However, I know that sounds super weird. Those managed identities can actually be found as separate resources here. I don't have any because why? I think it's not showing because this is only for user assigned managed identities, and I will get into that in a second. Okay, so when you create a resource, maybe at creation time or at a later time, you can come here and say, I want to assign an identity to this resource. That managed identity is tied to your resource. It's called the system assigned identity. When you delete the web app, that managed identity goes away, and then this becomes freaking orphaned. The entry inside my Key Vault will be orphaned. Doesn't do clever things to go and clear out all the access. So imagine having a web app that accesses storage and SQL and Key Vault and maybe other services. You have to go and clear out the orphaned managed identities. It's weird. So let's say I don't want to do that. I don't want to wipe out my managed identity every single time because I have the need for speed. I have the need to assign an identity that I own. Maybe the IT team will go and create managed identities with very specific permissions. Let's say a SQL managed identity and a storage managed identity. Then you can assign them here. I don't think I have any, to be honest. Ooh, it doesn't list them here. Yeah, I don't have any identities because I haven't created any. You can obviously create one, right? You can say, I want to, oh no, you can only add here. Or you can go back into the previous screen and add them. The idea here is that you segregate security even further. Rather than having one identity that can access everything, now you have one identity that can only read data from storage, and then have a separate identity that can read data from SQL, which is even more secure. And then another identity to only access secrets. Now you have better security. The benefit from doing that is that you can take the same identity now and give it to another resource. So maybe you have a web app and an API. Now the API can also access the secrets using that same identity. So you can reuse. They become reusable objects in effect, reusable identities. And they will live for as long as you want them to live. And then once they die or somebody deletes them, then they go away. But they're not tied to a service, which is great. How the hell does that work when it comes to code, you might ask, which is a great question. You see here, when you say I want to create a new Azure CLI credential or a new managed identity credential, in here you can now add a GUID. It's clever enough to give me a GUID. So 0000 -000, you know, you get a gist of it. And when I do that, the Azure Identity library will try to find that identity in the resource that you're using, which is great. So you can have an instantiated credential that uses that specific managed identity for Key Vault, and then you can have another instantiated credential that uses a different managed identity for storage. which is even better. Everybody with me so far? I hope you are. If you have any questions, let me know. Now we know the difference between a service principal, which is a username and password that you can create and assign to separate running tasks, to managed identities. And then within managed identities, we have system assigned identities, which are assigned and tied to a resource, and user assigned ones, which are independent managed identities that we can assign as we see fit. And this is great. So now the code runs in exact the same way. And the next thing I want to show you is how to deal with, how are we doing with time? 42 minutes. We got 15 minutes. Okay, cool. Oh no, I was going to show you how to do DevOps stuff. Let's see, is my Azure DevOps still there? Azure dev.azure.com. So we talked about code. Code is great, but we all know that we don't just create code, we deploy it somewhere. Sign into Azure DevOps. And people will use Azure DevOps or GitHub Actions. We'll see both and how we can benefit from identity in there. So here we have my, which demo is it? Azure Deploy App? No, I think it's the identity demo. Under code. Where's my code? Pipelines. What? I don't have any code here? Probably not. Let me find it. Azure Deploy App. Nope. That's not the one either. Sorry. It's been a while I've been here. Oh, Secure CSD. I mean, could I give it a better name? Summary, dashboard. Files. How many of you use ARM today to deploy or Bicep to deploy things? A few, I suspect. If you haven't changed to Bicep, you should. But let's say that you're still using ARM. So in ARM, you will have something like this, which is very tiny. You can't see it. So let's change that. It's a Sql deployment. We're deploying a Sql server with a Sql database. And up until very recently, to deploy a Sql server, you needed to have a username and password for the admin. Now you don't have to do that anymore because you can force Azure Active Directory authentication only. So you don't need an admin login and password. But for the sake of this example, let's say that I need something to pass to my deployment. And this is like 2 parameters. And many people would do this. Your login and your password. And obviously this is a paradise for attackers. We don't want to do that. I don't want to see secrets in your code after this session. If you don't remember anything else, if you don't remember my name, just remember this. Azure Key Vault is your friend. And we can take that parameters file and rewrite it using Key Vault. So instead of using hard-coded values, we go to Key Vault and say, hey, you know what? For this task, I want you to go and find me a specific reference. So in this Key Vault, the CM identity Key Vault, go and find me a secret. Does that secret exist? Let's find out. Obviously, it should exist, otherwise the demo wouldn't run. And in my secrets, I have my SQL administrator login and SQL administrator login password. And the whole point here is that when this task runs, it should, on the fly, replace them and pass them on to the deployment process. So how does this work then? Like, how does it know to authenticate? Well, we do have to create a service connection. Azure DevOps can be very clever and say, you know what, I think you're working with Azure. Let me go and create a service principal for you. So if I click on this one, it will open my Azure Key Vault, and I think it was too tiny to see. There you go. Manage service principal. And this will take me to my service principal, which has a name. Let me find a name because I don't remember. Azure DevOps Hosted. And if I go back into my Key Vault, I under my access policies, I don't think I've configured it, by the way. It might not work. Yes, it's not configured. So if I were to run this task right now, you know what? Let's kick it off. Why not? We'll see a big fat failure. You know why? Because at some point I had too many service principals and I went nuclear, let's delete all of them and see what breaks. So I can run it. And this is actually a very good practice. Not something you should do on your production tenant, but if you have a developer tenant that you use and you have lots of service principals, go and delete them and see what breaks. Don't break production systems. And there's a way to filter to the service principals that you only created yourselves. So this is you can do a list and then you can do a delete if you want. I knew more or less where I was using it and nothing in production. Therefore, I was more confident in doing that and breaking things. So somewhere here, we should see a failure, a big fat failure, because the deployment will not work. If it works, I'll be super surprised. Yeah, that's not me. That's a pipeline issue. Let it run. Let it simmer. Let's jump to GitHub while this is happening. GitHub. In fact, do I have Azure? I'll leave this open because we'll need it for our GitHub things. Now, on GitHub, we talked about, is it here? I think it is here. Is it here? Is it this repository? Yes, it is. Cool. Very tiny. Can't see. Okay, we have the exact same application. I'm deploying it all the time. And we do have an action, or actions, if you like. What does that do? They're all the same. MSI, SQL. Let me see the code. There should be a couple of workflows here. Yeah, okay. This is my main.yaml. If I were to run this in right now, it would go and get, obviously it's broken because wrong .NET version. We're on 7, so I need to fix that first. But the login, that Azure credential, it is something that you generate. In fact, it may have been deprecated already, so clear AZ login. I'll log in as myself now because I need to create a service principal to show you why you be using this one. Ta-da! Cool. And now let's go back here. It's gonna take a while to iterate through all my tenants. Let's go back to the running task and see what happens. Did that deploy? Deployment successful. So which? Now I am confused. It did service connection. CM internal. Wow. I am literally surprised right now because this should have failed. Unless I gave it a different name. Isn't that fun? Debugging in production. Azure DevOps hosted C5350. Either that or the object ID. Let's go back into our key vault. CM demo key vault. Oh, these are all my. Let me refresh. I won't do it. Certificates, access. It has cast the names now. It's definitely not this one. Terraform deployment CM demo. Could be this one. But I am. So let's see if I try to add it again, what name you will find. I'm telling you, surprised. I think it's the application ID. If not, it will be the key ID. Talking to myself like a crazy person. Okay, we just want secrets. So again, we want get and list, and then select a principal. Azure DevOps hosted. Did you see that? In the okay, so that's the right name. Or am I deploying somewhere? No, I am deploying here. No, you know what? I think I'm using no. Vault access policy, Azure Resource Management, yes. Oh, because I had that checked in, that works. Okay, cool. Let's go back. That solves the answer. Are you using? No, I'm not using a different key vault. I only have one key vault for my demos. Okay. Oh yeah, I wanted to show you this. Clear, then Azure AD SP create for RBAC. And I want it to be dastas SDK. Dastas. I think it's SDK auth, if I remember correctly. And then it will say, oh, I found this already. Oh no, it won't find it. So SDK auth will be deprecated. But now, right now, if you go to GitHub and you want to deploy to Azure, then you need to create this. You need to create this, take this JSON object, and you know it's a secret in there, right? Dump it into GitHub secrets. You need to create an Azure Key Vault secret, I think. Let me see here. You need to create a variable called Azure credential, and then the task will mention that or reference that and authenticate and do the deployment. But we don't want that because remember, they expire and things break. So what is the next best option? The next best option is to use something that we are waiting for it to be merged by the GitHub team that allows you to have a self-hosted agent, let's say a VM that you use for deployments. Oh, my camera went away. And it uses a mass identity. So this is a fork of the Azure CLI login. And we have a flag here called enable mass identity. The task that runs under that VM will have access to the underlying mass identity. And as long as that mass identity has the right permissions, it will be able to call into Key Vault, grab the secrets, and run them. And the next best thing, so this one uses a mass identity instead of a service principal. We said that. Perfect. And the next best thing is to use OpenID Connect. So with OpenID Connect, what we do here is we still have a couple of variables or 3 variables. Remember the client ID, which service principal we want to use, which tenant, which Azure Active Directory we want to use, and then which subscription are we authenticating against or for. And with that, the new login now creates that, has that, uses that trusted relationship between GitHub and Azure to exchange the GitHub token for an Azure token and then run the deployment. And this is where we need to go. Let's go to our Azure Active Directory. Home, Azure AD, just to show you how it's configured. And under app registrations, I have no idea what the name will be now. Azure DevOps Hosted. It is there. Azure DevOps Hosted is not the one I want. Oh, let's GitHub Action Hosted, GitHub Action OpenID Connect. Amply named. Under authentication, no, under secrets or credentials, certificates and secrets. Instead of using a hard-coded client secret, we create the federation. So we can do this, GitHub Action. Now, currently the scenarios are limited, but you should see a lot more as this edges towards GA. We want to edit that. I want to say, I want to use mine. Does it seem, remember correctly? Then the GitHub repository name should be, obviously I don't remember, but let's say we're doing this one. I would come here and copy that name, put it into my value here. Now, entity type, you can choose what you want that entity to be. It can be an environment, it can be a branch, so you can run this task only for main, or maybe only for develop, or a pull request, or finally a tag. Maybe specific tags allow you to run this deployment. So we can say branch, and I will say main. And let's down here at the subject identifier, everything changes to reflect the things up here. Combination of issuer and subject must be unique. It doesn't like it because I already have one configured, by the way. And finally, you give it a name. And what you end up with is, okay, thank you, with this. Exactly the same. Already configured for you and working out of the box. And if I were to run this task, let's go to here. Let's go to README. README. Fine, README. Edit. Hello. Let's edit the file. I'm not signed in, that's why. That explains it. So why cannot I edit that file? Let me find my two-factor auth. I hope everyone is using two-factor authentication. And then my GitHub account 933. Cool. Let's edit our README. Best Cleveland. Is it with a D or a T? Sorry. Submit. That's not like? At least it's my day-to-day, is it? Yes. And what? GitHub. What's wrong with you today? Or is it me? Test. I am stumped. Why can I not do changes here again? That's my repo, by the way. I'm signed in as myself. Attach files, dragging. No, I don't want to touch anything. What? Browser is broken. Browser is broken. No, it's not the browser, it's me. How the hell? I think I can rerun from here without having to. I thought you could rerun jobs. Build. I did sign in with the right account, right? Yeah. And I'm in the right repo. I'm losing my marbles right now. Yes, here. It feels like I'm locked out of my own repo right now, which makes no sense whatsoever. Actions, this one, which is active. And then I should be able to say, can we rerun this job? I thought, can somebody correct me that why I can't do that? Okay, let me sign out and sign in again. This is unexpected behavior. Sign in. Could be. Although I don't think so. Let me, yeah, branch policy maybe, but 0, 5, 6, 7, 1. Okay. Let's see, one more try. Like I've done this demo multiple times, so I don't know why it's different now. No, I don't want you. So here. Maybe. Okay. How about this? Code. Do we have any changes? No. Don't save. Let's edit the README file here and then do a push. Okay, you're out of sync right now. Git fetch. Cool. And I'm pretty sure that it's the README file. Close that. Don't save. Yes. Another demo. And save this. Cleveland type UG demo. Push. On the way. One way or another, we're going to run this demo. Nothing is stopping us, right? Let's go. Actions. There you go. Running fine. And this is going to use that specific OIDC login, right? You see it even says there, logging to the Azure Public Cloud. Done. I mean, that's the successful bit. The rest of the task can do whatever it needs to do because it is a contributor account, that specific one, to deploy to Azure, to one specific resource group though. So it's very scoped. And that's it. That takes us to the top of the hour. In fact, a full hour from the point I started. I would say again that if you only remember one thing from today's session, will be please don't use any secrets anywhere. Try to eliminate secrets as much as you can because this will make everybody else work harder when it comes to attacking your resources and getting access or unauthorized access to the things that you value. Key Vault is fantastic, but obviously you can use other tools. You can use a HashiCorp Key Vault, for example, running on Azure somewhere, so you can authenticate against the same principles. Try to avoid service principals as much as you can. If you cannot, then two things that you need to be super aware. Secrets expire, and you should be rolling your secrets very, very frequently to make sure that they are secured. If you need to use service principals on your machine to test things, then run them for a while and then delete them and then go use your own account in order to continue working. Again, service principals are something that shouldn't be lying around. Again, it's like having a username and password somewhere. Mass identities are available for most services. I would urge you to use them all the time if you can. I think it's the best thing since sliced bread. If you cannot, then look whether the workloads that you're running can support Azure Arc. And if not, then hopefully the Workload Identity Federation will come and help you even further with your tasks. The slides I can make available for you if you want, although there wasn't really a lot of meat in them. And make sure to follow us and subscribe on Tweets and Discord. Discord is a fantastic place. We have a very healthy community. And as some asked before, what I'm working right now, we have Workload Identity coming in the next few weeks. There will be also a workshop with some swag and stuff. So if you complete the workshop, then you can, get some free vouchers and stuff that we're planning on. And thanks everyone for listening and participating today.
Excellent. Thank you, Christos. We have one question in chat.
Are there any downsides with regards to service principals we should be aware of or control? With mass identities, no downside. The only thing that you need to be aware of, obviously, mass identities still need to be scoped. So when you give RBAC permissions to your mass identities, make sure that they follow the least privilege approach, because they can also be overprivileged. And if somebody deploys code to do things that that is not supposed to, then things could go bad. Like I used to work with Phil Winstanley, who is very well known in the security community. And every time we talked about security, he said your biggest threat is your developers. If you don't do proper threat management and code reviews, then developers can deploy anything they want in production. Who knows? Like I could be harvesting credit cards for that matter, or could be harvesting tokens and then reusing them somewhere else. So it's very, very important to do that. I would say mass identities, again, need to have the least amount of privileges that they need to operate in your solution. But don't expire, and they automatically roll the keys, so nobody has to worry about them. That was a great question. You're welcome.
Very good. Any other questions or comments for Christos?
And if you think about something that you don't want to ask now, or you haven't thought about, and then 2 weeks down the line, like, oh man, I wish I had asked that, find me on Twitter. My Twitter handle is under my picture here, and I'm always happy to communicate and help people over Twitter as well.
Very good.
You're welcome, Mark. Thanks, everyone.
Thank you. Before people start leaving for the evening, just have a couple of wrap-up announcements that I'd like to go over. And to go along with that, there's a few links in chat that I will touch on. So, Christos, if you don't mind, let me take back control.
Sure, go for it. Do I need to give you control? No, you got it.
I got it. Thank you. And let's minimize this. And there we go. All right, so in chat, I posted a few links regarding the resources, primarily the link to the YouTube channel, where the recording of this presentation will be edited and uploaded within the next few days. So strongly urge you to subscribe to the channel to get upload notifications. Also, tech events will be posted on my blog, and I also encourage you to subscribe to that to get updates, and we'll go over those in just a little bit. And last but not least, the feedback eval. If you would, please take a moment to fill that out so it can provide some creative or constructive criticism for Christos. As far as wrap-up events, on June 16th is the GLUGNet, or the Great Lakes Users Group.net, that meets online. And on June 23rd is the Cleveland C# VB.net user group. We're going to have Seth Juarez talking about, and the topic is Ask Me Anything About MachineLearning.net. So if you're interested in machine learning, that is definitely a great event to attend. And then virtual conferences listed below on the bottom of the slide, where you have June 6th through the 10th as the OWASP application security in the EU, and that's going to be online. On June 15th is the Azure Hybrid Multi-Cloud and Edge Day. And the link for that is, as you see there, Azure Hybrid Digital Event.eventcore.com. Rolls off the tongue. All these links will be made available on my blog, so you can click to them from there. On July 29th is JavaScript and Friends. On July 29th, the same day, which is a Friday, is also going to be Cincy Deliver down in Cincinnati. And they're going to have topics related to .NET development as well as Agile. On August 8th through the 10th is KCDC, or the Kansas City Developers Conference. And then August 17th through 19th is Codepalooza happening down in Louisville, Kentucky. As far as job openings, TechSystems always has jobs available, and you can find those at techsystems.com/itjobs. But as part of our weekly or monthly thing, we always like to ask who's hiring. So if your place of employment is looking to fill some positions and you have the links available, please put them in chat, or feel free to jump in verbally. Likewise, if you're looking for work, again, feel free to make yourself known, and we'll be happy to share that information with you. And lastly, my contact information if needed. You can email me at snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. My blog, as mentioned earlier, samnasser.blogspot.com, and I post not only tech events, but also articles related to various things in Azure as well as AI. And lastly, I invite you to connect with me on LinkedIn. Michael Batt just posted improving.com/careers for various job openings. So thank you for posting that, Mike. And if there's any other job postings, feel free to enter them into chat. If not, I'd like to thank you all for attending. And once again, thank you to Christos for taking the time to join us and provide some valuable information on service principals and managed identities. Thank you.
Hey, thanks for having me again. Have a lovely evening, everyone. Thank you.
All right, take care. Good night, everyone.